purpose here is to go through Bode's law as an example of what it means for something to be a scientific law. It's a thought exercise, something to get you thinking. As I've said elsewhere, I believe, I am never going to test you on the specifics of Bode's law. Not going to happen. On what it means to be a scientific law, by all means, yes, but not Bode's law in specific. So let's go look at it. Reminder first, in order to be a scientific law, you have to have supporting data. That's our scientific basis. We need to have the ability to make a prediction, and we have to be able to test that prediction. So, Bode's law. To begin with, for Bode's law, we take and we write 0 and 3. And then every other number after that is double the previous. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24, and we continue downward to 384. We then take these numbers and add 4. 4, 7, 10, 16, 28, 52, and so on down. The last step to actually get to Bode's law is dividing by 10. So instead of 4, 7, 10, we now have 0 0.4, 0 0.7, 1, 1.6. These numbers give the distance from the Earth, no, let me try that again, give the distance from the Sun to the Earth, one more time, the distance from the Sun to the planets in the solar system in astronomical units. 1 astronomical unit, by definition, is the distance from the Sun to the Earth. So you can see, third planet from the Sun is the Earth, and there the distance is 1. That looks reasonable. Now, Bode's law was developed, and in 1776, at the time of development, several planets were known. So here they are. Mercury was at 0.39, not too shabby agreement with 0.4. Venus at 0.72, also not bad agreement. Earth, by definition, at 1. Mars at 1.52, Bode's law says 1.6, not great agreement, but let's let it go. Jupiter, smack on at 5.2. Saturn is at 9.54 in reality, Bode's law says 10. Not great agreement, but let that one go as well for the moment. These are what was known at the time of development for Bode's law. Now, does Bode's law make a prediction? Yes, it says that there should be a planet at 2.8, a planet at 19.6, and one at 38.8. So let's move forward chronologically, because people took these numbers and started looking for planets. And the next one they discovered was Uranus. It's at 19.2. It was discovered in 1781. 19.2 to 19.6, again, not perfect agreement, but is it any worse than 10 to 9.54 at Saturn? Not really. Now let's think about that gap at 2.8. You're probably going, well, that looks suspicious, because we know there's no planet between Mars and Jupiter. However, there are some rather large asteroids, and Ceres happens to be exactly at 2.8. It was discovered in 1801. I believe Ceres is now one of the dwarf planets, like Pluto is a dwarf planet. Okay, so we have Bode's law. We have made a prediction. We have tested that prediction. We have one prediction left at 38.8. And regrettably, Bode's law just failed because they went looking. Neptune is at 30.1. Bode's law says nothing should be at 30.1 or even near it. And Pluto is at 39.4. 39.4 isn't horribly disagreeing from 38.8, especially compared to some of the others we have, but doesn't matter because there's still nothing matching Neptune. So if Bode's law were a law of physics, it just failed. We've just disproved it, right? But the question I have for you was, at the time of development, was it a law of physics to begin with? Did it have a scientific basis? If so, what? Did it make a prediction? We said yes, it did. Was it testable? Yes. We tested it, it failed. So think about that first bullet point. What is the scientific basis for writing down the numbers 0, 3, 6, 12 in the first place?